Folks, today we're talking about something truly exciting. Medium voltage power electronics. I know. Try to contain yourselves. Specifically, we're diving into the EasyPACK C-Series, which is designed for SST applications from Infineon, which sounds extremely serious. Because it is. Now, if you have ever thought, I wish my solid-state transformer solution was more compact, scalable, and optimized for high-voltage operation, then congratulations, you are in the right place. Because in this here Chalk Talk, we're going to break down how the EasyPACK C-Series can help engineers tackle high-voltage SST challenges without needing a room full of hardware, any amount of extraordinary feats, or several gallons of coffee. Although the coffee still helps. All right, let's get started. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, we're diving into a fascinating new development in power electronics for the grid with André Lenze from Infineon. André and I explore the benefits of the EasyPACK C-Series silicon carbide power modules. We also explore the various configurations included in the EasyPACK C-Series product family, the issues that degradation can cause in these types of applications, and how you can get started using the EasyPACK C-Series silicon carbide power modules for your next design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Infineon. Hi, Andre. Thank you so much for joining me.
Hi, thank you for having me.
Absolutely. Okay, so we're talking all about the EasyPACK C-Series silicon carbide power modules, which are designed for SST applications. So, Andre, before we dig into the details, talk to me about solid-state transformers.
For sure. So, in principle, there are many different kinds of SSTs in the making. In our context, we talk about SSTs for AC to DC conversion. And we have many new energies applications now out there, which are DC. And these applications are connected to an AC grid. And today, so-called medium voltage line frequency transformers steps down the voltage from a medium voltage level to a lower level, and then there is a conversion from AC to DC. And the target of an SST is now to replace this transformer and using latest power electronics and semiconductor technology instead. There are a bunch of advantages now compared to this traditional approach, which are namely better controllability, better efficiency, shorter lead times, and things like that. So it's a very attractive new application. For our conversation here, it would be great if we step a little bit deeper in the system itself. Let's have together a look on the slide. So as I said, an SST is nothing else than power electronics connected directly to the mains. And our customer typically make a design based on subsystems. So that means there are many subsystems cascaded in series. And now you have to imagine that each of the subsystems gives you a certain AC voltage, and all these subsystems added together, plus a certain redundancy and safety margin, is in sum the voltage level which you want to reach. And the important thing here is that the semiconductor voltage technology defines how many of these subsystems you basically need. As a matter of fact, the higher the semiconductor voltage, the less subsystem in series you need. And if we now do the math, and if we take the example of 34.5 kV, you can read out based on the graph on the right upper corner that a design for 34.5 kV based on 1200 volts would need more than 35 subsystems, while if you would decide to go for 3300 volt, you would only need less than 15. So there is a tremendous complexity reduction with higher voltage. And now, last but certainly not least, for the secondary side or the output side, here we see also value for lower voltage devices because depending on the end application, you need, for instance, 750 volt or 1200 volt devices. Yeah, so if we look to data center as an example, so plus minus 400 volt or 800 volt are needed.
So, EasyPACK silicon carbide power modules are capable of extending this voltage range. Is that right?
Oh, yeah, that's absolutely true. So we see big value of higher voltage devices in smaller package footprints. That's the reason why we are going to extend our Easy portfolio lineup to higher voltages. In this case, 3300 volt. We have decided to use our Easy package because without any doubt, the Easy package is the frame-based package which sets a standard for silicon carbide in the market. So you basically find this package in combination with silicon carbide in all of our applications, from solar to EV charging to uninterruptible power supplies and many, many more. It's a great package. And last year, we have launched already a new generation called C-Series, which we are going to reuse now, extending the voltage range. And the major features are mentioned here on the bottom of the slide. So you can expect from this kind of package a higher junction temperature and increased isolation voltage. We are going to implement high thermal performance substrate, new high current prints. We are going to make tailored chip technologies available. And last but certainly not least, we introduced here the so-called .xt technology, which is a superior interconnection technology.
So, Andre, what kind of configurations are we talking about for the EasyPACK C-Series?
There are many different kind of topologies out there, right? So it's of course not black and white, and a lot depends on preference, experience, and things like that. What we want to do now is we want to make a modular building block available for our customers, which provides a maximum flexibility. And that's why we decided to put here two separate half-bridge legs in our package. And by doing so, we provide a maximum on flexibility to the design engineers. So if they want to use this kind of product in a full bridge configuration, they can do so. If they want to use this kind of configuration in half bridge configuration, they can connect both legs with each other. If they want to use this design for 3-level LSC, they can connect both legs in a row. And last but certainly not least, they can also build an AMPC configuration based on this design. So it's really, really flexible.
Andre, these are for solutions that are SST applications operating at 34.5 kilovolt AC grids, right?
Yeah, that's true. This portfolio is for sure also downwards compatible, but we see a very, very clear and obvious trend towards 34.5 kV AC SSTs. And that's why we decided to make this package footprint available for the voltage classes 750 volt, 1200 volt, 2300 volt, and 3300 volt with silicon carbide MOSFET technology. And as I tried to explain before, this will provide a massive advantage for the SST application because on the input side, you need high voltage devices, while on the output side, you need the lower voltage devices. In addition, from strategic perspective, this package is a great fit as well because it covers not only the next step or the first wave of SST design, it will also cover the next waves. So the power will most probably in future go up. So right now we talk maybe about 3, 4, 5, 6 megawatt or so. But the next designs, which are on discussions, considering 9, 10, 11, or 12 megawatt. And both waves can basically be covered with this portfolio.
Okay, so what's the performance story here? And how does Infineon get these kind of low PPM rates?
As I tried to say before, solid state transformer will try to replace traditional transformer, which are proven reliable, right? Therefore, reliability is a crucial part for success. And since our devices are a key component in each SST, also the quality of our devices matters. And we typically consider application-related requirements and quality-related requirements during the device definition. So we make devices for this kind of application. In addition, we prove that with extensive reliability testing. And now, important to understand is that high voltage is not like low voltage. It's a totally new world or totally different world. And we can say that we as Infineon with frame-based modules have already decades of experience with high voltage devices, such as 6.5 kV silicon. In addition, we have also already a proven track record with high voltage silicon carbide easy modules in the field. So we have already multi-million large silicon carbide dies based on high voltage technology in the field. Statistics say that the quality level is on the same level than our overall silicon carbide easy portfolio. This is really a strong argument to use these devices.
Okay, so let's step back and talk about degradation. Walk me through what that looks like and the kind of issues it can cause.
Yeah, for sure. So here is another quality related topic. In this case, we talk about power cycling and lifetime. So you have to imagine that our devices are subject to temperature changes in the applications. So that means the temperature goes up and down all the time. And these temperature swings cause a certain stress on our devices and consumes lifetime. And for this kind of temperature swing, we need to distinguish between two different failure mechanisms. So we have the so-called bond wire liftoff, which has a consequence of higher drain source voltages. And we have the so-called solder degradation with the consequence of higher thermal resistance. Right now, the main failure mechanism for our classical easy silicon carbide products is solder degradation.
Okay, so the EasyPACK C-Series also contains .xt interconnect technology, correct? So talk to me about that.
So we see more and more new application rushing in with harsher emission profiles. This holds also true for the SST application in the data center context. And what we want to do is we want to make a technology available which can basically cover all these different emission profiles. And that's what we do with the .xt interconnection technology. So the .xt interconnection technology means that we improve both sides. So the front side metallization plus bonding technology, but also the die attach. And by doing so, we can increase the power cycling capability by more than a factor of 20. So it's really a massive improvement. And typically what we specify for our customer is shown on the right. So we plot for our customers the number of cycles over different delta T's, so changes in temperature. And by doing so, the customer is able to read out based on emission profile or based on the temperature swing, how much lifetime is consumed and how long the device would last. So with this improvement of more than 20, all problems are basically solved. And this gives a lot more freedom to designers. Designers, for instance, can now go to higher temperature without any compromise in lifetime and can squeeze out much more current than before.
Andre, does Infineon offer an evaluation board for the EasyPACK C-Series?
Yeah, for sure. So, I mean, here we talk about a new combination of high voltage devices and a new package footprint, right? So the Easy C-Series. And as always, we want to make the start for our customers as simple as possible. And that's why we designed a board for our 2.3 and 3.3 kV devices so that our customers can, without any problem, start testing, get a feeling about dynamic behavior, switching laws, performance, and things like this. Plus, they can derive first valuable information about gate driving and gate driver circuit and PCB routing. So all in all, it's a great starting point for our customers.
Okay, so what would you like my audience to take away from today's Chalk Talk?
I would say there are basically 6 important points. Let's quickly go through. So the first one is that we are going to introduce now a new easy portfolio, which is basically unique. So it offers a voltage range from 750 volt to 3300 volt and is especially designed for solid state transformer application. And then we are going to introduce tailored silicon carbide MOSFET chip technologies. So it doesn't matter if you talk about the input side and hard switching application or the DC-DC side and soft switching application. The MOSFET will deliver an unbelievable performance. We are going to introduce a flexible and modular building block, which allows each designer to build whatever kind of topologies he would like to build. Additionally, the .xt interconnection technology will solve all the problems in terms of lifetime. And with the high thermal performance substrate and our new pre-applied TIM, you can squeeze more out currents than ever. And last but certainly not least, we have decades of experience with high voltage devices, which is great for an application like solid state transformer.
Fantastic. Well, I think that's all I have time for today. Thank you so much for joining me, André.
Thank you very much.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Infineon. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EeJournal.